Start. Okay, good morning everyone and welcome to a rather blustery and cool day down in Hermanus. Hopefully it's better in your part of the world. It gives me pleasure to introduce this morning Nils Backeberg. He's the manager of the Steel Alloys Division and Mine to Market Research at Roskill, and he'll tell us a bit about Roskill later on after the presentation. Roskill has now newly been acquired by Wood Mackenzie. He brings academic rigor and industry experience to Roskill's market research and is a regular speaker on steel and alloy market developments and outlooks with a special focus on chromium. Before joining Roskill in 2017, he worked as an exploration geologist in rare earth deposits in South Africa, gold deposits in Canada, and geothermal projects in Guatemala. Nils completed his PhD at McGill University in structural economic geology of Archean gold, and after his PhD worked on rock mechanics of shale gas exploitation technologies at the University College of London. However, he stresses his home is in South Africa, where he completed his BSc and MSc degrees at the University of Cape Town. When he returned here in 2019 and heads up their local and regional office out of his home here in the Overberg. So he's one of ours, and we look forward to your presentation. Thanks, Nils. Good luck.
Cheers. Thank you. Thanks, John. Good morning, everyone. Thank you for the introduction, and it's a pleasure to be back on a South African geology forum. So the title of the talk today is sort of South Africa's role in the iron and steel industry through its geological heritage. Not going to focus much in the geology over the course of this, but really just focus in on sort of the key trends and narratives. And I'd like to use the presentation here as sort of a bit of discussion and talk a bit about the opportunities and challenges in South Africa. And I'm sure with the expertise on the call, we have a look more critically at the geology and how it could fit in with the forecast that we see. So let me click on the right page so it moves. So just a quick background in terms of what we do. So John mentioned I talk about Roskill at the end, so I'm actually going to start with that. But this slide here just showing you sort of in a sense also my career progression, sort of understanding Earth, Earth processes, the geology as we see it, exploration, and then we go further into mine development, and then we really need our friends in the engineering departments to keep us honest in terms of why we're doing what we're doing. And then last and foremost, you got sort of the end-use markets, and this drives the overall requirement for economic geology. John, sorry, can you all still hear this? My one screen's gone blank, and I've lost sight of who's on the call. Just to confirm, then I'll continue.
You're perfect.
You're fine.
Okay, and yeah, so this has really been quite interesting in terms of from my progression, understanding the importance of what the market drivers are and sort of the downstream drivers of exploration as understanding these markets. And then last, I've added an extra little arrow in here from the knives and forks back to our friends in the engineering departments. This is sort of that recycling loop that is quite an important trend when we're talking about sustainability of these industries. And 2021 has really been the year thus far where critical supply chains and sustainability of resource management has become very important to governments across the world. And we are actually seeing implementations of regulation and legislations in line with this. So it's a whole topic in itself that one can talk about. So just a quick introduction to Roskill, the work that I've been doing at the moment. So we're a research consultancy, and we look at sort of the mine to market analysis, understanding supply chains, and then the way we utilize this data is we forecast demand to try and understand what is the pressure on the supply chain, and then we forecast where could that supply come from to meet that demand. And then what most people pay for our research is that we come up with the price forecast, and sort of a supply chain analysis. Where are the cost opportunities in there? So that's really where people then pay for our research. We sort of rebranded the company as a critical material supply chain last year. And this has become more and more interesting and important, where countries are focusing in on where is the supply chain critically or at risk of supply, and how these markets can be built up more sustainably so that you can secure that supply. John mentioned we were acquired by Wood Mackenzie 2 weeks ago. So I'm operating under a new brand, Roskill, a Wood Mackenzie business. So we're still in the early processes of understanding how this fits in together, and we're marrying the two operations. Yeah, that's been a recent development, but Roskill as itself has been in operation since 1930 and is focused on metal market research since the 70s. Here's a suite of elements that we cover. A nice thing by covering rare earths, it adds a good sense of color to the periodic table, but sort of split into different divisions. We're looking at steel alloys is what I'm going to focus in today, but electric vehicle raw materials, technology metals, industrial minerals are sort of the key focuses of the company. Right. So today what I'd like to do is focus in a bit more about the background of steel, alloy ore, and the sort of the trends and narratives. What is the global picture of it? And where are sort of the key issues in the industry, and focusing in that on what is South Africa's role. So the last part of it is then just focusing on some key topics that are relevant to South Africa. And hopefully there'll be some questions from everyone here that we can talk about and dig into those in more detail. And there we go. So starting off with steel industry. Okay, so here we've got two figures that we put together recently for a new report that we put together. On the left, we're looking sort of at volume, and whereas on the right, we're looking at value. So what we're looking at here is contained metal consumption in stainless steel and also in carbon and other alloy steels. So the reason we've split up stainless steel, it's slightly more easy to understand that demand markets, whereas all the different alloy steels are much more niche markets. Carbon steel, so that's sort of crude steel production, is sort of the largest area itself, about 1.5 billion tons in volume, whereas stainless steel, we're talking about 50 million tons. And keeping that in mind, it actually shows, stainless steel alone counts for over a third of alloy consumption, so the metal that's alloyed with the iron. So really emphasizing the sort of alloy intensity of stainless steel. In terms of the alloys that sort of make the majority of the alloy markets, manganese by far the highest volume, silicon as well, very important in crude steel. And manganese and silicon are important because they're not only consumed as alloys, but they're pretty much involved in the steel making process in every type of steel, sort of deoxidizer, excuse me, as well, and sort of various applications besides alloying. But then if we look at chromium and nickel, the green and orange here, really determined by the stainless steel industry, and that's really where the main drivers of these metals go. So it's really related to the alloy intensive part. If we look at the value on the right, it's really nickel is sort of the one that shines out here in terms of its value, really outpacing the rest of it, and actually is the most valuable alloy in terms of total money spent on an annual basis that goes into the steel industry. This is when you also include external scrap, so scrap end-of-life material, and this is largely in the stainless steel industry. There is scrap used into carbon and other alloy steels, but this is largely for its iron contents. And so these graphs obviously ignoring the main metal used in this industry, being iron. So just focusing on the alloys that go with it. Manganese and chromium and silicon still have an important part of the value chain. Together, those three accounting for over 50%. But if you look on the right-hand side of the graph over here, it's stainless steel already is 50% of the total alloy market. So really emphasizing its alloy intensity. Why is this not changing? There we go. Right, and so here we're looking at a little bit, how have these markets evolved over time? So the figure at the top right here, this is global crude steel production and also forecast. So we're in 2021 now, here we go. Sort of our forecasts in here and also for crude stainless steel production. What's quite clear from this graph is I've highlighted here in the dark blue Chinese growth. And that really has underpinned the raw material requirements of this industry, with the rest of the world really remaining flat and already well established by the early 2000s. And then I'm showing the green mamba here. So South Africa's role in crude steel and stainless steel production is relatively limited, but we are on the supply chain there, and that is because, you know, there are materials available that are used in these industries. However, South Africa has not captured that value in terms of the growth. Now, moving forward, things are starting to change a little bit. In China, we are expecting crude steel production to reach a peak. And this is related to, you know, coming back to this whole sustainability conversation. This is related to China looking at the energy reform, sort of their tightness in energy supply, but also pollution controls and towards greenhouse gas emission targets. So this is something that's been expected to come online for some time. And you can see this is our latest forecast, or from about 3 months ago, where we've got 2021 just slightly above in China. But at the moment, there's sort of a battle between energy control in China, but also meeting demand. Demand is continuing to grow. And at the moment, or thus far in the year, and we're halfway through now, China is not meeting its goal to reduce crude steel output. So actually still increasing quite significantly year on year, with record levels of crude steel output. So, but as this changes, crude steel production should flatten off in China, and we'll see growth really continue elsewhere. And this is a lot of what we've seen happen in China is where there's an approach to reduce pollution. It's really just exporting that carbon footprint to other Southeast Asian countries, and that's something we've seen in the alloy industry as well, and I'll touch on that. In contrast to crude steel, the bottom right graph here is showing you the stainless steel, and we really think it's going to continue on its growth path, and this is because it is a higher value product. China is placing more value in terms of up-marketing their steel products, and stainless steel is part of that process, right? And so while we're seeing a flattening in overall crude steel, we think stainless steel is going to continue to grow, and it's still based largely around what's happening in China. And coming back to that graph on this slide, you know, that really places even more emphasis on chromium and nickel going into the stainless steel in terms of volume as well, but also in terms of value. And let's go back here. What these two line graphs are showing here is the value of the contained alloys in the steel industry. In this case now, excluding external scrap. So this is looking at primary material coming out of the ground. And so stainless steel will account for over half of the value of mined raw materials going into the steel industry by the end of this decade. So this is based on our forecasts of prices as well, but taking into account really what this is tracking is the growth in nickel as a key value, and in volume mainly tracking chromium. Right. So there's a bit of a background to what's happening in the steel industry and where we think that's going. So let's take a step back in the supply chain and look at the alloy production of this. Right. So I've split alloy production here into our bulk alloys, our stainless alloys, and our noble alloys. So bulks looking at manganese and silicon on the left here. So you can again see China in the dark blue, accounting for more than 50% of supply of manganese and silicon. So if going back again another couple of slides, you can see China accounts for over 50% of production of crude steel and stainless steel, which means that the alloy demand is reflective accordingly. And so the fact that manganese and silicon production is up in the 60%, China is effectively self-sufficient in terms of its supply. So it's not reliant on the rest of the world. And that means that this rest of the world supply is really its own supply chain outside of China. But so much so, ferrosilicon is an outlier that China actually exports significant volumes of ferrosilicon, whereas manganese is really just domestic. So in green here, showing you South Africa at the top, South Africa has never been one of the major producers of manganese or silicon alloys, but has always been a key part of the supply chains because, you know, we've got the manganese fields in the Kalahari manganese fields that really supply some of the world's, or there's a key part of the world supply chain. I'll come back onto that. But South African ferromanganese has halved over this last decade due to ongoing challenges. And what I wanted to highlight here is Malaysia in yellow has actually picked up some of that supply chain. And we've seen producers such as a company called Assor and African Rainbow Minerals, they've moved their alloy capacity for manganese from South Africa into Malaysia. And it's not because Malaysia has a domestic steel market. This is actually for an export market. So most of this is all exported to steel industries. Again, so this is a global market. And if we look at the growth has been in China, that really means that the alloy market outside of China has really quite been stagnant. And that's been one of the key issues that we've seen. Now, for stainless steel in the middle graph here, China accounts for less than 50% of supply. And now this is actually quite an important feature because it means that China is still reliant on imports from other sources. And this is where South Africa plays a key role. So showing you in green here, this is effectively only ferrochrome production. There's not much, if any, ferronickel supply out of South Africa. Right. South Africa used to be the largest ferrochrome producer, and I'll come back to that. But again, the growth has really been non-existent. The last ferrochrome or new plant site was built in 2012, and its second phase came online. This is Glencore's Lion plant in 2014. And since then, it's really been a story of shutting down furnaces rather than adding capacity. And in 2020, several plants closed down due to COVID to some extent, but they were already in the process of facing Section 189s. Where the companies were struggling given the markets at the time. Much like bulk alloys, this yellow bar is showing sort of new growth in alloy supply. And Indonesia, in this case, has been the key site for stainless alloy production. This is mainly focuses on the ferronickel supply chain. So Indonesia is one of the main suppliers of nickel ores or laterite ores that are used in NPI, so nickel pig iron production, which has really been a key source of nickel for the stainless steel industry, not used in many of the other, or not used at all in other nickel applications. But at the same time, Indonesia has invested in stainless steel production, so to consume its nickel ore domestically. And together with that, it has invested in ferrochrome capacity, despite not really having any ore to speak of. So it's reliant on imports of ores, much like China. And I'll touch on that in a little bit. So that's your stainless steel alloy layout. And then on the noble alloys, again, you've got China slightly below, but the second bar graph here, and I should have actually highlighted that, but that's Brazil, is mainly ferroniobium. This is effectively dominated by one company called CBMM in Brazil, and their supply arrangements or agreements and ownership with China. So again, China is quite self-sufficient. South Africa has a key role to play. Mainly this is represented, or this is only represented by ferrovanadium. So again, coming from the Bushveld. So the Bushveld has a key role to play for both stainless and noble alloys, whereas for the bulks, we're talking about the manganese fields in the Kalahari. Right. So just to summarize a little bit about how this growth has been reflected in the alloys. So the graphs here, just plotting production on the x-axis against exports, sort of a proxy for international trade. I'm going to skip talking about the noble alloys here on the right, and focusing here on the bulk and stainless alloys. So you can see in what this graph is showing is a time series from 2011 through to 2020. You can see nicely the impact of COVID-19 in terms of production. But most of the growth for manganese has been captured by what's called silica manganese, whereas high carbon ferromanganese has been not seen slight growth in volumes, but nothing significant. So that's been relatively flat. Ferrochrome has also seen significant growth in that market, as well as ferronickel here in green. Now, the interesting thing that we can see from these graphs is sort of the trend in exports together with the growth in production. For ferrochrome and silica manganese, that growth is flat, right? So just flat to the right, increase in the market size, but the international trade has really not changed. So what this is telling us is that the ferroalloy production is or the growth is taking place where the stainless steel demand is, or the steel demand is downstream, right? And so effectively, I showed the growth in the steel industry has been in China. So this is showing investment in capacity in China, showing this flat demand. And ferrochromium here, again, sitting as sort of the highest traded volume of an alloy. And that is really reflected of the import reliance of China. I'd mentioned for manganese, China is self-sufficient. So what this is tracking here, this external, this export market, is really an international trade that is already existing and is really not changing that much, whereas the growth in the supply has been domestic to China. So why this is important is because for ferronickel, things look very different. Right here, we've got growth in the market, similar volumes in terms of gross weight alloy supply, but the export market has really ramped up for ferronickel. And what this is showing us is that China has been unable to capture that market and has been reliant on imports. And the story here is that in Indonesia, we had an export ban on nickel ores, first in 2014 and then again in 2020. And so production increased, but China has become more and more reliant on importing the alloy rather than the ore because of these export bans. So it's an interesting discussion, interesting example to use when looking at some of the South Africa specific commodities. Right. So coming to ore production, so the presentation mentioned iron ore. I'm not going to speak too much about iron ore, but I thought I'd throw this in quickly. I've taken off the axes here because it's not my data to share or the company's data to share as such. So, but just to show you some of the key trends. In South Africa, we know that iron ore is a key part of the economy here. But on the global scheme of things, it has not been the major driver compared to the other ore alloys that I'll be looking at after this. So really the market has been captured in Australia and in Brazil, naturally also being a key supplier to that industry. But superimposing our forecasts for the crude steel industry, this is that billion-ton market moving up to 2 billion tons, we're expecting a limitation in the growth for iron ore. Now, this is an interesting narrative. If you've been following the iron ore price, it's really been driven, or it's been skyrocketing this last year. It was one of the highest year-on-year increases in terms of metal price in 2020. But that wasn't just related to demand growth. It was partly related to Chinese steel industry continuing to grow while COVID-19 saw closures and restrictions elsewhere. China still had record production of crude steel in 2020. But at the same time, we've got international trade issues between Australia and China, closures of mines in Brazil, and Vale's issues from mine issues taking material off the market. So there was a distinct shortage or distinct fear of shortage in China on iron ore, which drove up that prices. But longer term, we don't expect prices to stay as elevated as they are at the moment, given the fundamentals of the steel industry that we're seeing. In terms of South Africa's role, shown here again as the green mamba, yes, it's an important part of the supply chain, but not one that really has captured much of the growth of the industry that has been there. Right. Coming back to the ores, I'm showing you here chromium, manganese, and nickel. I think because those are really more important in terms of their international trade outline, whereas vanadium and niobium, molybdenum and silicon, there are some nuances to their ore supply, but not something that's quite critical. So starting on the left, chromium ore, you can see there South Africa, Kazakhstan, and India account for the majority of the supply. Kazakhstan and India is really a domestic market feeding domestic alloy industries, whereas South Africa has its large alloy industry, but really South Africa has captured the growth in requirements in China, so servicing an international supply chain. On the manganese ore side, slightly more diversified compared to chromium. Again, South Africa, the largest producer, Australia, the second largest there, but some of the mines in Australia reaching end of life. And there's some potential restrictions coming up there, although lots of projects available. Manganese is getting attention from the battery industry, so there's lots of focus. And then you've also got Gabon and Ghana in here as well. So in terms of an African supply, really critical to the overall supply chain in here. And then for nickel ores, the growth here, again, I've mentioned Indonesia, so there's been a switch over to laterite type ores, which is feeding NPI, so this lower grade ferronickel, which is suitable for stainless steel consumption. And you can see here on the bottom graph, Indonesia, the largest supplier together with the Philippines really, But in 2014, you can see that supply drop off quite significantly. And this was the export ban that was imposed in Indonesia on nickel ores in order to capture alloy markets. So they're basically looking for investment into nickel processing in Indonesia. Now, the export ban relaxed somewhat in 2015, and China started importing lower grade ores for its nickel pig iron production again. But in 2020, Indonesia reimposed an export ban. But you can see that this time the ore production didn't drop as much. And this is showing us how much investment there's been into alloy processing, because this was all processed domestically in Indonesia. Largely, it's been Chinese companies investing in alloy capacity, but you can clearly see a big difference in terms of what that impact was of an export ban into 2014 and into 2020. So an interesting example to show how politics plays in with the geology. Now, coming into the importance of alloys, this is sort of critical raw material studies in the alloy industry. So with a focus on sustainability and supply chain risks, here's sort of the major countries that have done detailed assessments, and we've worked with them on these to some extent, trying to identify what is the supply risk for certain metals. So I've only listed here the steel alloy materials that we cover at Roskill, and you can see that all of them are identified as key risks. So it's not just because of the electrification of the automotive industry, where there's a lot of weight currently being put on lithium, cobalt, graphite, etc., to meet the demand of these new energy technologies. The steel industry is still an important part of the global supply chain, and you can see from the assessment done globally how they've placed value on this, with chromium and manganese identified in nearly every region. The EU and Europe in general, they've got their own supply sources and not as critical there. And China, I think we'll see manganese get a tick here in their next assessment, because domestic supplies of ore in China have been reducing, so they're becoming more and more reliant on imports of that material. Okay, right, so that sets the background a bit, and now I'm going to come in and drop into some of the settings and the scenarios that we see in South Africa. So focusing on what's the position of South Africa, where are the opportunities, also what are the challenges, and this is really what I'd like to just sort of set as the scene for discussion. So the first part of it, let's start with the headwinds, and really the alloy supply chain in South Africa has been dwindling. It's really been struggling, and there goes my screen. There it goes, it comes back. So here's sort of the three main alloys I've left off: ferrosilicon and silicon metal, which is also part of supply in South Africa, but not one where the ore has an important role. But here you can see ferrochrome. South Africa used to be the largest ferrochrome producer in the world. This is benefiting from its geological heritage of the Bushveld igneous complex, with close to surface, high volume, relatively cheap to exploit resources. And we also used to have the cheapest electricity for alloy producing countries to process this into ferroalloys. But you can see, as I mentioned, the last plant was built in 2012 and 2014, upgraded, and since then supply has been very stagnant. And then, we're expecting potentially some recovery, but over the long term we're expecting it to decline. Most of that growth has been in China. For silicon manganese, South Africa never had a big focus on there. Unfortunately, from the manganese perspective, this has been where all the growth has been. Most of South Africa's focus was in ferromanganese, or high carbon ferromanganese. And you can see here the closure of furnaces over 2015 into 16. And that was sort of that migration towards Malaysia that I mentioned earlier. But relative to the markets, ferromanganese has been largely flat. So this was a non-growth market in terms of its demand. And that's largely supported by the furnaces here closing off, with the focus being more on silicon manganese. And one of the key issues is that these markets are all fundamentally driven by the costs. They are bulk materials. That's the price of the material is really determined by the cost of production to meet demand. So, I mean, China consumes, 1.2 million tons of chrome ore every month. And that converts to 600,000 tons of ferrochrome more or less every month. So these are high volume materials that are constantly being consumed. And so fundamentally, these kind of markets are driven by their costs. Now, I mentioned South Africa used to have one of the cheapest electricities, and that's what the graph here on the left is showing you, is that just electricity tariffs in South Africa and China in US dollar terms, so taking exchange rates into account. So you can see South Africa at the moment is really elevated. This is our recent increase here in 2021. Also a strengthening of the rand, which didn't help this process when last we plotted this graph. I mean, the rand dropped to 13.5 to the dollar. And this has really underpinned the fact that South African ferroalloys industry is sort of at a tipping point, right? Between 2011 and 2016, if the tariffs were still increasing in rand terms, but this was a depreciation period for the rand, and actually supported a lot of the production in South Africa at this time here, so 2011 to 2015, to continue operating despite markets being actually relatively weak. But you can see here into 2016, tariffs increased, and this is really where we saw ferromanganese drop off its margin and went out the window. So this is really one of the key issues looking forward. And for 2022, we're expecting another 15% hike in electricity costs. So this is something that we probably can expect to see move further out of parity, and really is one of the main issues for the industry. So because of that, and we do have the world-class geological heritage in the country. So here's looking at Bushveld, the Kalahari, and iron ore areas here. We've got some rare earth deposits. But most of the industry now, from the ore perspective, is built on an export market. And that is because the domestic processing has really struggled to be able to keep track with that. And they're getting quite inventive. So for manganese, most of Port Elizabeth was the designed export ore for manganese, but it wasn't able to keep pace with demand. And so on the bottom right, this graph, what I'm showing you is manganese export by port. So Durban quickly became another export port. And then Saldanha, this is then where manganese started to jump on board the iron train and get to Saldanha. And then more interestingly now, you've even got things going by Cape Town, going out by containers, Richards Bay, a recent addition. And then this last year in 2020, we've had ores exit via Lüderitz. And, in terms of distance to port, you can choose a direction to get to coast, and it's more or less 1,000 kilometers to get there. So it really is a high cost to get this material to port and to ore and over to China. For chromium, it's a similar situation, not quite as expensive as manganese, but really also Richards Bay was its main export port, and really diversified in all these three ports, Durban, Richards Bay, Maputo, now flogging high volumes. And this Maputo port was quite critical during the COVID period because this border control caused a severe bottleneck in terms of material leaving the country. So we actually had trucks going back and forth here to try and find out where they could jump on ships. And now more recently, the shipping industry is completely out of sync with supply, and costs are really high. So this is all very important for the South African industry, the focus on the ores and high volume materials moving. And people are becoming quite inventive of how to get material out the market, and it makes sense for the alloy industry to have developed. We have the resources, we have everything we need, but the demand market further downstream is still in China. China looked at investing into stainless steel or steel capacity in South Africa, and they're still investigating it. But because of the issues from Eskom, they really pulled out of those plans. Now, more recently, they've just started building a new crude steel plant in Zimbabwe, taking advantage of those and looking to invest into ferrochrome capacity there. So, missed opportunities from that perspective as well to talk about. And this is really just emphasizing how that market has grown against, so summarizing what I've been talking about. So then blue here, this is your chromium ore exports. I mentioned the import reliance from China on South Africa is quite critical. So chromium, this is a normalized graph to 100 here in 2004. And then manganese ore as well. And then iron ore has also increased somewhat, but not capturing the same growth in the market. Whereas if you look at the alloy side, been very flat, and manganese and ferrosilicon, dropping off relative to their historical levels. So these are very key trends, and we're expecting this to continue. If we look at the forecast, the chromium demand from the stainless steel is looking to increase. South Africa is a key supply chain for that. Manganese, Chinese domestic supply is reducing, so it will require more South African material, even though the growth in the industry is not as significant compared to chromium. So there's still opportunities for growth for ore supply because there's dwindling resources elsewhere. So just emphasizing that point on a global map. So focusing in on China, where it sources its steel raw materials. So Indonesia and Philippines for nickel, and last year no nickel supply, or low because of that export ban. For manganese, slightly more diversified, but South Africa accounted for 43% of exports to China. For chromium last year, we were 82% of exports. And this puts an interesting question in terms of export policies in there. South Africa is talking about an export tax on chromium ores, and this will have a significant impact on the market because China will not be able to replace 82% of its supply to meet its ferroalloy demand. In the nickel narrative, they have been closing down, or the ferronickel plants have been short of supply and are actually starting to switch to ferrochrome and other alloys, in order to continue to operate, or they are closing down. All right. So this is just emphasizing that from this criticality, from the critical raw material supply chain, but focusing in on China. So chromium, South Africa accounts here for 75 up to 80% of supply. Manganese ore has becoming more critical in China as the time goes by, and this is because of that dwindling resource. Again, slightly more diversified, not as critical as chrome, but still South Africa has a key role to play, coming up towards 50% of supply to China, right? So again, this is a highly critical environment. And looking at nickel, again, as sort of that poster child of how this can be done. China imports mainly from Philippines and Indonesia, and depending on what the export policy is from Indonesia, has been able to decrease its criticality to a single source. But again, in 2020, with that export ban, really reliant only on one source of supply. So, something that the government is looking at, should be looking at more closely to understand, what are the impacts, opportunities, and also threats to the markets from investment perspectives, etc. So here's showing that just in another graph, chrome ore supply really related to South Africa. Zimbabwe is also they tried an export ban earlier in the decade, and it pretty much failed. It didn't do its due, and they opened that back up. So Zimbabwe is coming back on the market, but its resources don't compare in terms of the availability of the Bushveld igneous complex. So South Africa really is a key part of that supply chain. In terms of the growth in manganese ore, again, South Africa really is set to remain part of that supply chain. And here, just looking at Indonesia exports to China, and you can really see how an export policy has impacted that. So this is looking at exports to China. And so here's that first export ban, and then the next one over here. So something to think about, it's something to talk about. What are those impacts? Is it a good thing to imply an export ban or an export tax? I think these are all interesting topics to discuss. And, bearing in mind, so here's a picture from Dwarsrivier, 80% of supply to China is from South African bushveld, and from the Kalahari manganese field, currently we're talking 43% of supply. Right, so that was about 40 minutes, and I'm going to leave that there and open up to any questions and see if there's anything that we can discuss from that perspective. Thank you.
Fantastic, thanks, Nils. Do you want to unload your screen, and then we'll open up to questions? I'm sure there'll be plenty. I certainly have a few.
Okay, yeah, sure.
Right. Okay, either hands up or pile in. Who wants to start? Any?
Maybe just beneficiation. Where do we stand with that? What is the sort of impetus there, or is it just the ore that we have to concentrate on?
You mean in terms of technology, or in supporting raw materials to do the beneficiation?
Wow, what is the opinion on that one? Which is the best way to go?
Look, if we're talking beneficiation, I think UG2 from the chrome perspective is an interesting example to chat about. You've got run-of-mine material leaving the country. The Chinese will take what they need for their raw material demand. but it becomes a value question. Is it worth the investment or not? At the moment, anything sells. We've got countries like Oman entering the supply chain and producing very low grade run of mine ores that are happily taken into the market. The interesting thing with the stainless steel industry is that they've been quite happy to consume lower grade materials and lower grade alloys as a result of those materials. So there hasn't been that focus on beneficiation to upgrade ores to that same extent. There are benefits to it, of course, but I think that's really an investment and a net payback question rather than a technology issue.
Yeah, I'm just looking at the long distances. You know, if you could get that a better quality product there, because the sort of immediate thought one has on taxes is that it becomes a little bit of an incentive for other people to produce more. And so you might, in the long run, start losing your capacity as a supplier.
Yeah, exactly. I mean, this is exactly the discussions that I've been having with the industry, and we're quite involved in trying to understand what those impacts are. And one of the questions is, you know, if you have an export tax, the chemicals industry, from a chromium perspective, they're trying to argue that it is a beneficiated product. It's not a raw material, so should it be taxed? But it's exported under the same trade codes, so it will be taxed, because otherwise you need other admin in order to get to that level. So yeah, we would see an export tax, would probably see beneficiation increase to C, but it will only work if it falls outside into a different tax code, trade code. Otherwise, there's no way for them to manage that. So this whole story has a lot of admin related around it, and at the moment, I mean, you know, they addressed this in October. The government came out and gave their talk, and I think this last budget speech in February was the first time that the global chromium industry tuned into the South African budget speech to see what they say. But nothing was mentioned, and I think they're still looking at it. And you know, it's in terms of access to cash, it's a quick way for the government to make money. Will they lose supply? Probably. But South Africa, you're not going to replace 11 million tons of chromite ore to China in terms of export. China will have to import some. The analysis I did, there's probably 2 million tons that you'd lose relatively quickly. And then depending on the cost position, there's up to about 5 million tons that can be lost. Now, if we look at domestic consumption, we're talking about that 5 million tons could reignite all those idle furnaces. So, you know, when this is the balance that needs to be drawn at the moment, but restarting those idle furnaces, you still need to compete with China. And at the moment, that balance is in parity. Yes, an export tax will add cost to China. But with tariffs continuing to increase, it's a short-term solution at the moment. And so this is the problem. Every time I look at it in a bit more detail, you know, there's opportunity there, but unless there is investment and support to the alloying industry, the beneficiation part is not really going to add much benefit, in my opinion.
Yeah, and also just to add to that, you can't run big furnaces if you don't have consistent base load, you know, read Eskom. And then, you know, the other side of it, and we've seen it at Richards Bay, and it's happened in the Eastern Transvaal, in Mpumalanga, you know, the whole community issue is also, you know, not going to help. And so, you know, and then obviously there's the cost increase too. So it's just, you know, it's just a huge lost opportunity for South Africa that we just don't have, you know, we don't have the political will. And I think most of all, we don't have the understanding. And it's very interesting. We've just had I just helped a student do a study of the small diamond mining sector. And we don't even have a mineral economics department in the DMR anymore. You know, we used to have quite a good one, and there'd be regular, you know, annual reports. The last diamond information we could find went back to 2015, and I think that applies on all the commodities. So, you know, government can't make decisions and understand, what's going on unless they have decent info, the sort of info that you have. And I think that's another big problem for government.
Yeah, no, I mean, I completely agree. And I try to talk to the DMRE and I keep telling them we need to work for them. But as of yet, they've not. It's a difficult one to get them to chat in more detail on that. But there are huge opportunities, and they always have been. This is the problem, right? But it really has been a struggle for the industry to capture that.
Yeah. Right. Other questions? Okay, and I have another sort of kind of curveball question for you, and I've been there and seen it. So you look at the extent of illegal chrome mining, and it's quite staggering. And you see these double link, truck and trailer systems pull up at these illegal operations, and they get loaded, with no problem. Regularly, it happens overnight, and they get shipped. Where's that ore being shipped out of? Is that being shipped out of Mozambique? Because again, it's a bulk commodity. It's not a bunch of diamonds in a back pocket.
Yeah, illegal exports from South Africa were probably up to about, from chromium alone, just over 1 million tons. So, it's not an insignificant volume. If you consider 10 million tons being exported to China, that's 10% of that market.
Yeah.
It originally picked up a lot in the Eastern Bushvelds, but most of those easy pickings have kind of been gone. You had mines where at night they'd come in with the front-end loader, pick up the ores, and then drive off. And you'd see the damage to the fences where they entered and exited and, got back on the highway. That has slowed down quite a lot, not because they found hearts, but because the easy pickings are starting to dwindle a bit more. But what you're seeing at the moment is that the illegal chromite industry has moved back to the Western Bush, not back, it's moved into the Western Bushveld.
Yeah.
And this is now looking at these wash plants, because, once, it doesn't matter where the ore comes through, and if it gets filtered through a wash plant, there's no traceability for that. So it really filters back into the official system that way, rather than getting to ports. But the Eastern Bushveld definitely, most likely predominantly left via Maputo. But right now, things are a lot more complicated to trace, with these wash plants really putting anything and everything together. I know that my family up there, they've got a farm in Kroondal, and there's piles of chromite sitting on their land, and there's nothing they can do about it. And it's not their workings. So and this is daylight. This is happening in the middle of the day. There's not much being done to it, but this is not illegal ground mining happening on the property. And it's a bit
it's a pity we don't have Paul Miller on the call, but I mean, he has built his own databases because we don't have a cadastral system, you can't find anything. Paul has put all these things, on a map. You can actually do it from Google Map these days. The quality is so good. And, Paul has information on his database, which is, you can rest assured, nowhere in a government DMR database.
Yeah, no, I've had a good chat with Paul, and I had a look at his data. It's very good.
Yeah. All right. Other questions?
Now, apart from just talking about it, once we've accepted that the government is not going to be able to do it for a while, are there private incentives? Are you talking to the companies? Are you actually taking PR out to the clients overseas, making that connection, starting to show the government if they do it that way, then it will work?
So we're probably not as involved as South African would like to be, but what we are doing is we are connecting supply chains internationally. I mean, we've got offices in China and here, so we are talking to the companies in China, and they're asking us a lot about what's happening in South Africa. They're looking to invest in South Africa because chromium, more so than manganese, really is a critical material for them. And if South Africa closes borders, that whole industry is going to go belly up in China to some extent. It will filter out somewhere, but the costs will change completely. So there are opportunities. The ferroalloy industry is very consolidated now. It's effectively Glencore and Samancor that are operating these plants. Samancor is now owned by Chinese consortium completely as of last year. So that is an integrated supply chain to China. And so they have an incentive to keep the alloy industry going. That's what it was purchased for. Whereas Glencore is mainly a miner in terms of its other commodities and trader. And there's always been a question what their long-term plans are with assets. I mean, and John, you mentioned sort of the community issues. I mean, the Leidenberg plant in the Eastern Bushveld was closed last year. Yet on a cost basis, it's actually highly competitive. It uses Primus technology, which is sort of the most energy efficient cost technology used in the ferroalloy industry. And so despite its cost position, it was closed down. They've costed their plants differently. They basically say the cost has to compete with, the plant has to compete with the price that they could sell the ore internationally to. So they lose all of the advantage of having domestic supply. They actually have to pay market price for their ore and compete on the alloy that way. And by doing that, the alloy competitiveness goes completely out the window. So it's an interesting, it really is an interesting issue. If you compare that to the manganese alloy industry, which has already started to pack up and leave. And at the moment, there's actually a new opportunity because China has closed down small furnaces. And there's actually been a squeeze on supply in China. And this is why currently the South African ferrochrome industry is operating at quite high capacity again. But this is an opportunity at the moment because China is doing a structural reform, energy reform. But all of the investment in new capacity is currently in China and in Indonesia. And there's currently 3.5 million tons of ferrochrome capacity being built in China and Indonesia, which is based on consuming South African ores. So that opportunity will go away very quickly.
John Blaine has his hand up.
Yeah, okay, Niels, that was fascinating, and equally will be interesting to come and see your backyard when times permit. But a little background, I worked with Falkenbush for a long time, and of course I can always remember a lot of their discussions in nickel predictions and stuff was all about stainless steel, and they had operations not only in sulfide, but and that was in Canada, but also in laterites in the Dominican Republic initially, and then more latterly in New Caledonia. Yeah. But what I can always remember the story about the nickel laterite, that basically they gave away the iron content for free because it was part of that whole pig iron story, and it was really a big money spinner. But certainly went through populations. Another little link to that was that they were also part of the early investigations in deep sea nodule mining for manganese and nickel and all the rest of it. And it's interesting to see that coming back into the news again, although I have a feeling the green departments are going to have a serious problem with that aspect, never mind the technology, which not can be mitigated now, but was certainly a challenge back in the 70s. Yeah. But I think coming back home here, I think the rather telling thing is that ARM Minerals would see fit to export its sort of processing facilities to a more beneficial country, such as Malaysia. And well done to the Malaysians for attracting that. And I think it's something that really should be shoved in the nose of the powers that be in this country, because if our prime BEE representative cannot see fit to stay in South Africa, then they've got a really hard thing coming on. I find that really sad.
Yeah, no, I think that narrative is quite ingrained in this industry because the raw materials are here. I mean, if South Africa had nickel supply more, we do have some coming as byproducts out of our PGMs. There was the Nkomati mine as well, but that one's closed down now. So it could support some scale of a stainless steel industry, but more regionally, if we look at Southern Africa as a whole, there are huge resources here beyond the steel industry with lots of opportunities remaining in place. And you mentioned the iron credits. This is one of the key reasons where China's really dominated in the stainless steel industry. It gets its free iron from the NPI, but similarly, the chromium industry, the charge chrome, which is 50% chrome rather than 65, it's getting an extra 15% iron for free. The chromium industry, they've tried to sell their iron before, but they just get laughed at. And last year with the iron prices, they were weeping at a missed opportunity there. But this is how the industry has evolved, and they're struggling to get any value for iron, and they probably won't. And yeah, this is one of the key advantages that China has invested into, and that's very hard to compete against them.
Yeah. Just anyone else there?
John has got his hand up again. I've just muted him because he's giving some sound feedback. Try again, John. Just unmute yourself.
Yeah, okay. So, Nils, just there, you mentioned that South Africa doesn't have a stainless steel industry. We did have. And I don't remember the details of where all the supply was coming from to produce that, but I have a feeling that a lot of it was imported raw material as well to set that up, because that was a bit of a sanctions busting thing at the time, if I recall rightly. Yeah,
I mean, the Columbus plant, I mean, it's still operating small volumes. I mean, it used to be connected to the what's now operated by Afrak, the Mokgale alloys, because Mokgale used to produce a nickel chromium alloy as part of that, which was small volumes, but that was using largely scrap stainless steel to produce a new alloy to feed into the plant. But yeah, you're absolutely right. I mean, but longer term, the focus, there's different stainless steel products. You've got the ferritic stainless steel, which is no nickel, and then you've got sort of low nickel 200 series, but the main market has been the nickel bearing stainless steel, mainly because it looks nice.
Yeah, actually, just a reference back to the past. I remember at Falconbridge that stainless scrap was a very significant business driver, because they take container loads of just about everything from kitchen sinks to workshop tools to cuttings from aircraft engine making and stuff, and they just ship it off to Sudbury, pump it into the smelter, and then of course they send it off to Christiansand to do all the separate metal separating. It was a very lucrative business, even though it's a very small percentage worldwide of total input to the industries. It certainly was a money maker in those days. I'm not sure what it is now, but I'm sure it does exist, and it does all around and makes lots of money.
Yeah, no, absolutely. It does still exist. And I mean, the USA's stainless steel production consumes 60% of its raw materials from scrap. Europe is sitting at over 50%. But the key reason why the focus hasn't been there, because the growth has been in China. And China's end of life scrap stainless steel industry is still evolving. There's not as much scrap availability. But 2017, based on our data, is where we're actually seeing scrap availability in China start to increase for the first time. So we will see scrap consumption in China start to increase, and that'll have a significant change on the raw material requirements moving forward, for sure.
Yeah, and I mean, John, you raise a very valid point. Just look at the towns and cities around South Africa, and the scrap metal business is massive. Whether it's manholes or people's taps, a la the Johannesburg Museum. I mean, it's just scary stuff.
Yeah, no, absolutely.
Yeah.
Thanks, Nils.
Right. Yeah. Just the last question from me again, and it's a sort of indirect question. I mean, the other, you showed a very interesting map towards the end on South Africa and the distance to ports, and that gets back to infrastructure. And I think again, we saw Exxaro, I think it was last week, complaining bitterly about not being able to get their coal exports to the ports. And again, we drove the highway from Harrismith to Johannesburg, Pretoria last week, and there's miles and miles and miles of the highway between Harrismith or the N3 being rebuilt, because when you see the volume of big trucks and ore carriers on that road, there's just no ways that road can hold up. So, my other concern, or I'm sure concern for all these mineral exporters, is just, the infrastructure. Is it going to be sustainable?
Yeah. No, I mean, this is trucking has become such a key part of the supply chain just to meet the demand volumes that are leaving the country. rail capacity is declining rather than increasing. Okay, they're making a few longer trains here and there so that they're still getting a net increase in volume. But, you know, last year during the first COVID lockdown, you saw the vandalism across the train stations, and, you know, Transnet to some extent was, you know, quite happy because it was one less service line to worry about. And so they're just focusing in on sort of that key network, those key arteries going between Joburg and Durban, or in Richards Bay, really. But the capacity is not there to keep pace with demand, and people are putting it on trucks and are being competitive, you know, low bedding it. We've got a very interesting chap that I met in Durban. He supplies pick and pay inland, and then has converted his truck that he can load up with chromium and take it back to port. Obviously, it has to meet food standards, that it's not toxic in any ways, and chromium meets those standards apparently. But, you know, people are becoming quite entrepreneurial in terms of getting material to port.
Yeah, except you and I are paying for it.
Well, I mean, yeah.
Okay, other questions? Any last comments? Any?
John, could I ask a question?
Yeah, sure.
John,
please.
Can you hear me? You know,
Yes,
in all of this, forgive me for asking something that's very patently important in my life, but in terms of anything to do with the metallurgical industry, you do need coal.
Yeah.
You need the carbon in the reduction process, quite apart from the electrodes, etc., etc. Has anyone given any thought to that?
Yeah, I mean, so as a research side, we don't focus too much on that, but the metallurgical coal, it's a small volume compared to thermal coal, but in terms of where South Africa stands on that, we actually import the large majority of our metallurgical coal to meet the requirements here. And there's sort of a 10,000 ton shipment that comes in once a year from the Ukraine or something like that, and is a key part of this budget. You're absolutely right. People are looking at different approaches to use domestic resources, but the large volume their market is thermal coal. And so capturing that is a difficult side of things. But with the whole energy transition, I think this will be an even more interesting project to look at, because depending on how the energy supply chain works in terms of renewable energy, and we are seeing reliance on coal-based energy reduce in certain regions, not here, but we've seen the recent announcements of private energy to South Africa. This will really start to drive energy transition phase here. So it's definitely an interesting one to follow. It will have an impact on the alloy industry, but at the moment, the South African coal industry is not that important for the alloying industry side of things. It's mainly imported, unfortunately.
Nils, just another question. You talk about the silicon. I mean, most of the silicon presumably comes along with the ore, but I mean, where you need silicon, where do they get their silicon from? I mean,
so I've been working with one of my colleagues who does our silicon research, and they get there from their quartz sites and quartzes. He talks about, and in terms of the ore side of things, it's never been an issue. Now, you can talk about high purity quartz versus quartz that's suitable for ferrosilicon production, where you don't need that high purity.
Yeah.
That's another conversation to have, because the high purity silicon is probably more important for the silicon metal industry, and that is the main growth market. Silicon, in terms of quartz supply, it's not something that's internationally traded a lot, because you can find quartz anywhere, pretty much. But in terms of its resources for ferrosilicon, it's never been something that's that critically looked at. It's not been something that's been shortage of supply. But also as a market in its own, it's been quite stagnant. Ferrosilicon consumption in steel is mainly to use as a deoxifier during the steel making process, so you get rid of all your oxygen bubbles at the end of the process. So it has an important role to play, but its growth market's been pretty flat, and most of the focus is actually on silicon metal, which is used in solar panels and those kind of things.
Yeah. Okay.
So I don't know too much about that side. I've had various people come try and talk to me about high purity quartzite or quartz, but I don't know much about that.
Okay, we'll let you off that one. But thanks, Rosemary. I mean, we still got to talk to you about doing clean coal and a coal talk. I mean, coal shouldn't be going away in a hurry, or I'm sure won't go away in a hurry.
Sure.
Well, thank you, everybody. As you'll notice, we're going into recess now, so don't have any withdrawal symptoms. For the next month or so, we'll be concentrating on the illegal liquor supply chain. So we'll be back early in August for you guys. So watch the space.
Okay, so we will also get a program out in the next few days just for the second half of the year, and it's looking quite good. So there'll be lots of good stuff coming along. But thanks, Henny. Thanks, Gert, for standing by. Thanks, everyone, for your questions. And thanks, Nils. That was excellent. I mean, we all, need iron and steel every day of our lives, but we don't really understand the whole business. So thanks for that. That was excellent.
No, I appreciate that. Thank you for your time, everyone. And yeah, see you all soon.
Yeah. Okay. And we'll be looking forward to the braai down there when you have some decent weather in your part of the Overberg.
Yeah, that's fine. Well, you should be able to just look out the window. You can see if the sun's shining.
Okay. Thanks,
Thank you, guys. See you next month.
Cheers. Bye-bye.
Bye now.